Hello dear students, in this small video we are going to analyze and learn about the motion and the types of motion and all the important key point related to the motion. So here is a motion. What is the motion? The first question we are going to answer in this video. Second, what are the different types of motion? Third, what is the physics relating to the motion called? And the last, okay, we have answered to all these questions. Okay, so moving on, and here we have what is the motion as the first question. So when a body is continuously changing its position with respect to the surrounding, then we say that the body is in motion. So the first answer of the first question is that. And then we have examples. Suppose that when an athlete is running on the ground, then he is continuously changing his position with respect to the audience who are sitting at the rest. And the second example we are continuously changing our position since morning till night with respect to the earth which is at rest. And the third and the last example for the motion is the earth is continuously changing position with respect to sun which is at rest. So here we go. What are the different types of motion as the second question? So here are the different types of motion. One by one we are going to discuss. First is the linear motion. When a body moves either in a straight line or along a curved path, then we can say that it is executing the linear motion. When a body moves in a straight line, then the linear motion is called the rectilinear motion. That means the linear motion further classify between some other types of motion as we have seen here. So for example, an athlete running a 100-meter race along a straight track is said to be linear motion or rectilinear motion, right? Then the second, when a body moves along a curved path, then the linear motion is called curvilinear motion. Then that linear motion is called the curvilinear motion. So a plant revolving around its parent star is an example of that, right? And the next one we have other types of motion are second motion types of motion. The main second type of motion is rotatory motion. A body is said to be in rotatory motion when it stays at one place and turn around and around about an axis. If the axis is fixed, again and again the rotatory motion. Okay, done. So the example for this is a rotating fan, a spinning top, the earth. Okay, and the last one, the oscillatory motion. A body is said to be in oscillatory motion when it swings to and fro about a mean position, like when your phone is when you kept your phone on the surface and it's vibrate, same type of motion. For example, the pendulum of a clock, the swing, etc. And again we have what is the physics relating to the motion called. So here we have answer mechanics. It is important branch of physics and deal with the effect or force on the body. That means the causes of the force on any body we see is just because of this. It is further divided into two parts. Which part? First is dynamic. In the dynamic we discuss the motion of body under the action of force, and the second is kinematics. So the famous, it deal with the study of motion of body without any reference to the cause of motion. That means we don't need to care about the causes of it. So again we have one of the most important concept of kinematics, or mainly we can say that in the classic physics, which is vector and the scalar. So what about this? The motion of object can be described by words such as distance, displacement, speed, velocity and acceleration. These mathematical quantities which are used to describe the motion of objects can be divided into two categories. The quantity is either a vector or a scalar. These two categories can be distinguished from one another by their distinct definition. So the definition for a scalar are those quantities which are fully described by magnitude. Example: displacement, velocity, force, acceleration. It means to describe the scalar quantity we do not need the direction. But in case of vector quantity, our quantity which are fully described by both a quantity and a direction, along with it also follows the vector laws of algebra. For example, it's a triangular law, polygon law of addition, or parallelogram law of addition. So example are distance, mass, time, volume, etc.